It is now time for us to study in deep about the oxides of nitrogen. So the first one is dinitrogen oxide, that is N2O or laughing gas. Now it is also called as nitrous oxide. It is stable and colorless gas. It is a linear molecule and is also used as an anesthetic. It has all the electrons paired, and since all its electrons are paired, it is diamagnetic in nature. And this is how its Lewis structure looks like. The next one that we have is nitric oxide or nitrogen monoxide, or its formula being NO. It is the most stable oxide of nitrogen. N and O together have 11 valence electrons. It has an odd number of electrons in its molecules, hence it is paramagnetic, and it acts as an oxidizing as well as a reducing agent. And this is how its Lewis structure looks like. Also, it dimerizes, and this is the dimeric structure of NO, and we find this dimeric structure in the liquid and solid form, where it behaves as a diamagnetic material. Now that means NO in the gaseous state is paramagnetic, whereas in the dimeric state it is diamagnetic. Next we have nitrogen dioxide, that is NO2. It is an acidic oxide. It is reddish brown in color and it's gaseous in state. It is paramagnetic. Therefore it will have at least one unpaired electron, and which is evident from its Lewis structures. Now it dimerizes to form N2O4. So 2NO2, it dimerizes to give us N2O4. And above we have its structure. Then another important fact that we learned in the previous module is that NO2 dissolves in water to give nitrous and nitric acids. Let us have a look at its reaction. NO2 plus H2O gives 2HNO2 and HNO3. HNO2 is called as nitrous acid and HNO3 is called as nitric acid. Moving ahead, we have our next oxide, that is dinitrogen trioxide, which is N2O3. It is an acidic oxide. It is also known as nitrogen sesquioxide. Then it is diamagnetic. And this is how its Lewis structures look like. We do not have any unpaired electrons. That means all of them are paired. Hence it behaves like a diamagnet. Then it is a planar molecule as suggested by its structure above. We now will go to the next one, that is dinitrogen tetroxide, which is N2O4. It is an acidic oxide. It has no unpaired electrons. It is therefore diamagnetic in nature. And this is how its Lewis structure looks like. There are no unpaired electrons. And this is how its structure looks like. Therefore, it's a planar molecule. The next one that we have is dinitrogen pentoxide, which is N2O5. It is an unstable acidic oxide. It is an excellent oxidizing agent because it is unstable and thus highly reactive. It has a symmetrical and a linear structure, and it has no unpaired electrons. And this is how its structure looks like. Now N2O5 is also an anhydride of nitric acid, and then we have nitric acid here. To that we add P4O10. Now P4O10 acts like a dehydrating agent. So it takes away one molecule of water, and whatever we are left behind with is N2O5. Or in other words, we can write it this way also. We have HNO3, to that we add P4O10. It results in the formation of HPO3 and N2O5. In either case, we call N2O5 as the anhydride of nitric acid. With this knowledge, let us solve MCQs. The first question for you is, which of the following can be used as anesthesia? Our options are N2O, NO, NCl3, NO2. And we have our answer here. It is used as an anesthetic and the gas is N2O. So our answer is option A, N2O. The second question that we have is, which one of the following oxides of nitrogen is the anhydride of HNO3? We have just learned this, we have just seen this. NO, N2O3, N2O4, N2O5. Just for our memory's sake, let us have a look at this. And we know the answer, that it is N2O5. So the correct answer is option D, N2O5. The next one that I have for you is, of the following which is paramagnetic and has odd number of electrons in its structure? N2O, NO, N2O3 and N2O5. So as we can see, the oxide that we have here is NO, and it has an odd electrons molecule, and below that you can see that it is paramagnetic. So our answer is option B, NO.